back. This is video 10 in a series of videos where I talk about a Desmos activity called Make Them Balance. This is page 10, and here you're asked, are you ready for more? You can click I'm ready. And now you're going to see find values for x and y so that both hangers balance. Press try it to see if the hangers balance. So this is probably the most challenging problem that I've seen in this whole activity. And the reason it's so challenging is because you have two hangers that you want to balance at the same time. You've got this bigger hanger that you want to balance, and then this smaller hanger that you want to balance. So we need the bigger system to balance as well as the little system to balance at the same time. So trying out numbers, you could just kind of plug and chug. So I'm going to erase everything. And we could try numbers for x and then see if it works. So if, say, x is equal to 3, if we choose x to be 3, then we've got 1, 2, 3, 4, 5, 6 threes here. So this side here will be 18. And then we've got 9 here. We want this entire system on this side to be 18 since we need this. Let me use a different pen. Since we want this side and this side to balance, then that means that these 4 y's, they must add to some number that's going to add to 9, and then that's going to be 18, right? So we need this whole system to be 9 plus 4y is equal to 18 because we want this bigger hanger to balance. So this equation, I can actually solve the equation. It's a two-step equation. 4y plus 9 is equal to 18. I subtract 9 from both sides. 4y is equal to 9. I divide both sides by 4. And then that implies that y is equal to 2.25. And then we can try that here, 2.25, and click try it. None of the hangers, neither of the hangers is balanced. So we did something wrong. And I can see my mistake right away. I said 3 plus 3 is 9, which in fact it is 6. So let's erase some things and try this again. Okay, so we had said that I'm going to finish up this problem where I assume x is equal to 3, or I just give x a value. I decide, okay, well, let's see what happens when x is equal to 3. When x is equal to 3, we had said that here we have 3, 3, 3, and then altogether that's going to be 18. And then my mistake earlier was saying that this was 9, but this is actually 6. So we have 4y plus 6. We want that to be equal to 18, right? Because we want this side, the left side of the bigger hanger, to equal the right side of the bigger hanger. And on the right side, we've got 2x, which together is going to be 6, plus 4y, that's going to have to be 18. So to solve this two-step equation, subtract 6 from both sides. 4y is equal to 12. Divide by 4 both sides. Y is equal to 3. So let's try and see if that balances. Okay, so we have the bigger hanger balances, but the smaller one doesn't. And so what I can do is continue what I just did. So I can continue this process with different values of x and then figure out the values of y that match. And eventually, if I do this for a very long time, eventually I will probably find the two values that make both hangers balance. But that's just going to take too long. So instead, what I am going to do is I'm going to look at the smaller system and I'm going to say this side needs to equal this side. So 2x must equal 4y. And also, this whole system has to equal this system. So 3x plus 3 has to equal 2x plus 4y. This is my first equation. This is my second equation. So what I can do is I can write two equations, one for the smaller system, for the lower hanger, and another one for the bigger hanger, for the entire system. And I can think through what two values will make both equations equal at the same time. And again, that's going to take me kind of some time. But if you remember from the previous pages in this activity, if you go back, we had seen, and I'm going to take us back, we had seen that if we could graph two equations, if we could graph the equations that we were given, and if we could find the point where the two equations meet, then that would tell us the point that would make both of these equations equal at the same time. So I'm going to do that, and I'm going to use, I'm going to do that, just that. I'm going to graph equation 1, I'm going to graph equation 2, and then I'm going to look at the point where they meet. So in order to do this, I'm going to open up another, I'm going to open up a graphing tool called Desmos. So you just go to desmos.com, and from there you can graph these two equations. So let's try it and see if Desmos can graph it for us. And it did. It graphed the first equation for us. So the first equation is 2x is equal to 4y. So I graphed that one. And then I'll just graph the second one. And now I've got two lines, and they meet at the point 3, 1.5. So let's see if that point will make the equation balance. Okay, it didn't, so we did something wrong. I know what I did wrong. When I wrote my equations, so let's click try again. I had said that equation 2 was 3x plus 3, but it's not 3. It's in fact 3 3's, right? This piece is actually 9. So this 3 right here needs to be 9. I knew I had done this wrong because I had tried it before and it didn't look like that. So if we change that to 9, we get a different point of intersection on the graph, and I can just grab this graph and move it till I get to where I want to be. 9 and comma 4.5. Try it. And now my system balances. My hangers balance. All right, so like I said, this is probably the most challenging problem out of all of the problems that you've seen. And if you don't understand any one detail, or if you have questions on any one detail, you can let me know. But it's really, this is pretty challenging and advanced. So if there are little confusions and little things that you don't understand, you should realize that this is a little bit higher than your level. And so if there's anything that you don't understand and don't get, that is okay. It doesn't mean that you're behind in any way. This is just a very challenging problem. So I will do one more video on screen 11, so stay tuned for that, and thanks for joining me here.